Hello.
Hello.
Yeah, can you hear me?
Yes, sir.
Okay, so what has been going on last few days?
Actually, last few days I had my board practical exams,
Hmm.
so I had to prepare for those.
Okay. Uh, do you have any doubts and all that you have to ask?
Yeah, there's a few.
Share them. Okay. Two cards from a pack of 52 cards are lost. Two cards from 52 are lost. From the remaining pack of cards, two cards are drawn and found to be both aces. Remaining 50, you have drawn two, and these are both aces. Okay, then the probability of the lost card being at least one ace. Probability of the lost cards having at least one ace, right? Right. So we have to find out the probability of lost cards having at least one ace. So
Right,
lost cards could have one ace, or lost cards have two aces.
right. Yeah,
Have two aces. This is the probability that we want. So we want probability of X union Y, right?
right,
If you call this as X and this as Y, so we will get that by doing Px plus Py minus Px intersection Y is not possible, I think, right? You cannot have lost card having one ace and lost card have two
yeah.
aces.
Uh,
I mean, it will be same as X.
yeah,
No, no, there is no intersection, right?
yeah. Right,
These are independent events.
right,
I mean, these are mutually exclusive,
right,
right? So this is zero. So basically, you just have find px plus py.
right.
So, okay. So now you split the problem into parts. This is the given data, right?
Yeah,
This is given. Now we have to find probability of lost cards have one ace given out of the remaining 50, you have drawn two aces, right?
yeah,
Two aces out of 50. So if we call this event as X and if you call this event as A, you have to find probability of X given A, right?
right.
So basically that is probability X given A will be probability of, no, wait one second. We have to find probability of X, right?
Yeah,
We can think about it, but we don't know it right now, this thing, right?
right,
This would be probability of X intersection A by probability of A.
right.
But our job is to find probability of X, right?
Yeah.
Okay. So feels like maybe I'm approaching it in a slightly different, wrong way. I could have done it like this. Probability of, uh, I'm trying to think of Bayes rule. So Probability of the two. Okay, I have taken the wrong approach. We should have done 1 minus probability of no aces in the lost cards, right?
Right. Okay. Yeah. Yeah.
That would be much better, no?
Yeah. Okay.
So we'll just calculate this.
Right.
So we'll so we are going to assume that there are no aces in the lost cards,
Right.
and we are given the information that the two cards drawn are found to be ace from the remaining 50.
Yeah.
Right. So probability of that event, probability of no aces in the lost cards. Given that that has happened, right?
Yeah.
So it would be probability of no aces intersection with two aces divided by probability of two aces, right?
Right. Yeah.
So no aces there and intersection with two aces. So that means, okay, so now we count how many ways this can happen, right? So you can select two cards which will be lost, but you cannot select them from the aces, right?
Yeah. So that
So
will be 48 C2.
48C2 ways you can select those.
Right.
And after that, number of ways this can happen.
50 C 50 C2 then.
Two aces have come when you selected randomly, right?
Oh no, it'll be
So it will
50
be,
C1 and then 49 C1. Or
no,
1 in 50 into 1 in 49.
right. So there are two aces. So in our situation, no aces were selected first, right? The
Right.
lost, no aces were lost.
Right.
So all four aces are there, right?
Yeah.
Correct.
Yeah.
So you have to set, and here, when you picked out two out of those 50, they turned out to be both aces,
Yeah.
right?
Right.
So it would be basically 4C2, no? You selected two, but you actually selected it out of those four only, right?
But we would have drawn it from the remaining pack, which has 50 cards.
So we'll divide that by the total number of ways to
Ah,
select two,
okay.
right?
Okay. Right. Yeah.
Do you understand what I'm saying?
Yeah.
So this is actually selecting the lost cards, how many ways?
Right. Yeah.
This is selecting the ace cards here, right?
Right.
And this is the total number of ways to draw two cards,
Right. Yeah.
right?
Right.
Uh, but wait, am I sure I'm doing the probability right? Uh, Probability of no aces intersection with this probability. These are two events. They are independent events. We can multiply their probabilities, right?
Yeah.
What is the probability of no aces being drawn out of the two lost cards? So we are doing it wrong. We have to do 48C2 divided by 52C2, right? This is the probability that no aces were lost.
Yeah. But I thought that the denominator will cancel out anyway.
I don't know. I'm just
Okay.
verifying again.
Okay. Right.
Multiply it by the probability that two aces. Denominator is cancelling out. How?
I thought, yeah, it won't. It won't. Right.
Probability of two aces out of the remaining ones, right? So you're selecting two out of 50. Total number of A's are 50C2.
Yeah.
And on top, you have only selected aces. So out of four only you can select, right?
Right.
So this, right?
Yeah.
This should be the top probability.
Yeah. Right.
And you have to divide it by the probability of just this much, right?
Yeah.
Probability of two aces coming from the thing, right?
Yeah.
So that could have happened. Okay, okay. Right. So there are multiple cases there, no? Do you understand what I'm saying?
Yeah.
Basically, it's like probability of two aces could have happened if first step was one ace, right?
Yeah.
Right? And it would have been two aces lost or zero aces lost, right?
Right. Yeah.
So this term will be there in the denominator, but there are two other terms also.
Right.
Do you understand?
Yeah.
It is straightforward only.
Yeah.
So for example, this case, probability that you got two aces in the last bit would be if one ace was already lost. So that means you selected one ace and the remaining cards, one card you selected from the remaining 51, right?
Yeah.
So 4C1 into 51C1, right?
Yeah.
Divided by 52C2, right?
Right. Yeah.
This is the required probability of losing one ace.
Yeah.
And then after that, you got two aces. So that means out of the three remaining aces, you selected two, right?
Yeah.
Divided by 50C2,
50C2.
right?
Right.
And similarly, you'll get a term like this here, no?
Yeah.
So that term would be, so technically we are doing Bayes' theorem now,
Yeah.
the stuff that we are supposed to do. So uh, this term would be 4C2, select two aces to get lost,
Right.
and then remaining nothing, right? That's
Yeah.
it. Divided by 52C2.
Right.
Probability of losing two aces multiplied by now probability of still getting two aces. So there is only one way,
Yeah.
2C2
Right.
divided by 50C2.
Right.
So these three terms have to be added, right?
Yeah.
And the numerator is this again.
Yeah. Right.
So denominators, one, all of them have the same denominator, so you can remove them automatically.
Right.
It will be the ratio of uh, right. So you're getting 4 into 51C1 plus no into 3 plus 6 into 1
Um,
plus 48C2 into 6, right?
right.
So you have to divide 48C2 into 6 divided by this stuff.
Yeah.
12 into 51 plus 6 into 1 plus 48C2 into 6, right?
Right.
48C2 into 6 would become 48 into 47 by 2, right?
Yeah.
So it is coming on top 24 into 6, 144 into 47 on top,
Yeah. Right.
divided by this part is going to be same. So 144 into 47 plus 6 plus 51 into 12. So 510 into 102. So 612, right?
Right.
Okay. So this is the probability we are getting here. Now we can cancel a 6 from everything. So 24, 24, 1, and 102, right?
Right.
And we are getting 24 into 47 by 24 into 47 plus 1 plus 103.
Yeah.
47
Right.
by 24 into 47 plus 103. Okay. And we have to do 1 minus
One
this, right?
minus is.
So 1 minus this would become 103 by 24 into 47 plus 103, right?
Yeah.
Correct. So now we have to calculate this. Uh,
102.
why?
103. Oh, never mind. Yeah, yeah.
We are subtracting, right?
Yeah, yeah.
So 576, okay, 24 into 48 is not there. Okay, we have to calculate it. 470, 940, and then 47 into 4, right? 940 plus 47 into 4 is 188, I think, right? So it is 12, 1, so 11. 1128 plus
Yeah,
103.
right,
So 1231, right?
right.
We are getting 103 by 1231, which is a weird answer, but is it divisible by something? 1003 is a prime, though. It is not divisible. Something is wrong. 1 second. Where did you get the question?
It was in a test a few days ago.
Do you have answers or something?
Yeah, I think, yeah, it's there.
Check once. A is the answer, okay?
1 second. Yeah, A is the answer.
It's very similar. We have made some small mistake somewhere. Can you see?
Yeah,
It's almost the same thing.
yeah,
6 less, 6 less. Something has gone wrong somewhere. Check the solution. You have the solution?
yeah, they've put it up.
Check the solution. The
Uh,
method should be the same, I
it
think.
is this. It is the same method.
So the numbers we have made some mistakes somewhere. You will do probability of on top, you will do how many ways could that happen? 48. You lost two aces,
Yeah,
and still got two aces.
yeah,
Divided by, you will do three cases. Lost zero, got two, plus lost one, got two, plus lost two, got two. Now, maybe somewhere we have made a mistake in the probability terms. So check what is the wrong thing. They should get fractions like we got only.
even they're working, it looks the same only, the number that they've gotten.
Then maybe the answer is wrong, but you should check the calculation once. But the
Yeah,
concept is clear, right?
yeah, yeah, I got it.
Right. What is the next one?
1 second.
Okay. Let integral e power x plus x square 2x square plus 3x plus 2 dx is equal to f of x plus c, where f of 0 is equal to 3. You have to find f of minus 1. Okay. Right. Hmm. X plus x square is here.
Yeah,
So we can write f dash x is directly this, but that won't help us. Ultimately, we'll have to integrate it. So, okay, obvious thing is x plus x square is my variable, right?
right.
To convert it into the e power t ft plus f dash t form, right?
Yeah,
So 1 plus 2x dx is dt. We have to think about, can we take out 2x plus 1 from here somehow? So we can actually, I think. Can we? 2x plus 1? No. It's not factorizing, right?
It's not.
Right. So, okay. Right. So the obvious thing is not directly working, but
Yeah.
x plus x square. So 2x square plus 2x plus x plus 2. We're getting 2 times x plus x square plus x plus 2.
Right.
So, right. Hmm. Okay. Let's not worry about trying to fit it, because that's the mistake that might take a lot of time to try to fit it in the form, right?
Yeah.
Let's just approach it in a different way. We have integration by parts. We'll differentiate this, right?
Yeah.
No, but we can't. We can't integrate this.
Can't
That's the
integrate.
issue.
And the other way also, it doesn't lead to anything.
Have you checked it?
Yeah, I did it.
You checked integration by parts here.
Yeah.
Hmm. Okay, fine. So, plus x square. Okay. So this is equal to this.
Yeah. And if we can factorize the 2 out of the thing and then try that, but I tried that also. I wasn't getting anything.
Or x into x plus 1. They are asking us for f of minus 1. What happens if you try to put minus 1 into it? E power minus 1 plus 1, 2 minus 3 plus 2 dx is equal to f of minus 1 plus c, right?
Right.
So we are getting integral dx is equal to f of minus 1 plus c, right?
Yeah.
This is becoming x plus some k, right?
Oh, but that doesn't make sense.
But this has to come out with some constant. fx plus c. If I differentiate it, I'm getting f dash x is equal to e power x plus x square into 2x square plus 3x plus 2.
Right.
So I have dy by dx. Mhm. So basically, there is nothing we can do except integrate.
Yeah.
Right. So 2x square plus 3x plus 2 has to be written in terms of, okay, we'll just try it then.
Sir, could you try integration by parts? Because maybe I made a mistake.
We can try it, but see, we can't integrate it, so we have to keep it as first function.
Yeah.
This has to be second function. So it will be e power x plus x square times integral of this. So that will be 2 by 3x cube plus 3 by 2x square plus 2x, right?
Right.
Minus derivative of this, which will be e power x plus x square into 2x plus 1 into this, right?
Right. Right.
So to multiply by 6, so it will become 4x cube plus 9x square plus 12x.
Right.
Now, the hope is that this is easier to simplify, or it fits in the pattern that we need, right?
Yeah. I should divide by 6 as well.
Where?
You multiply it by 6, so
Hmm. Right, so by 6. So this is fourth degree stuff here.
yeah.
Okay, we can take x common. We're getting 2x squared plus x. That doesn't help us. Basically, the point is that if we have to do the same thing here, we could have tried it here, right?
Yeah.
So let's not do this because it is just a bigger thing. Let's try to get it from here only then. I want to write 2x squared plus 3x plus 2 in terms of some function of x plus x squared and its derivative.
Right. Yeah.
Now, if you think about it, this has to be a linear function, right?
Right. Yeah.
Because if you have a linear function, then only the output will be quadratic.
Yeah.
So I will take a random linear function a times x plus x squared plus b, right?
Right. Yeah.
Let's say it is f of x was ax plus b,
Right.
right?
Yeah.
Plus I have to do derivative of that f of x, right?
Yeah.
But I have to do derivative of this thing.
Yeah.
So it will be a times 2x plus 1, right?
Right.
And now we'll get a and b. Do you understand?
Yeah. Yeah.
Basically, now I'm doing brute force, right?
Yeah.
Because there's no way to nicely guess it. It's not so easy to guess.
Right. Yeah.
So I have to write the required 2x squared plus 3x plus 2 in terms of this thing. I'm going
Right.
to assume it's a random function of this plus the derivative, right?
Yeah.
So now you have to think of polynomials. It has to be a linear polynomial. It can't be quadratic
Yeah.
because then the power would have been much higher,
Right.
right?
Yeah.
So let's see that now. We'll get
So
ax square plus 2ax plus ax. So 3ax plus b plus a, right?
yeah.
So a is, this is what is coming, but
doesn't fit.
It's not fitting. What is the mistake here? 1 second. Okay, one mistake I can see. Uh, if I had taken it as a variable, I need it to look like this: e power t f of t plus f dash t dt, right?
Yeah.
Correct. Then
Yeah.
only I know the integral.
Yeah.
But I have not taken into account the derivative. It should be outside also like this, right?
Ah, okay. Right.
So dx, if I take t as this, x plus x square, dt is equal to 2x plus 1 into dx, right?
Right. Yeah.
So dx is basically dt by 2x plus 1, right?
Yeah.
So if I replace dx, I will have to write dt by 2x plus 1.
Right. Yeah.
So here, when I take it as f of x and all, I have to divide it also then, right?
Yeah. So we'll have to multiply that LHS by 2x plus 1.
Right. Then it is not coming linear then, no.
It won't be linear. It could be cubic.
This side is a cubic,
Yeah.
so then this has to be a quadratic at least, right?
But if we put quadratic, then we're putting a quadratic in a. Oh, it might cancel out. Okay. Yeah.
I mean, the next higher degree you have to check, no? You
Yeah.
can't
Yeah.
directly go to cube and all.
Right.
Should be some quadratic of it. So let's just do the general thing. Ax square plus x square plus bx plus x square, this whole square, plus c, plus this will become, derivative of this would become 2 times, but this is too long. This can't be done like this. We are missing something. I mean, this was asked in your Allen test.
Yeah.
Then the solution has to be small or something, right? Can't be asking such questions then.
Yeah.
Was it in the score test or something?
Uh.
It was in which test paper?
Yeah. This was score test.
We are missing some obvious thing. Let's try to figure out what is there. We can write it like this, right?
Yeah.
That's the same thing.
Yeah.
This is,
Yeah.
okay, so Don't really know what will happen here. But check the solution. What is the solution saying?
1 second.
Feel like they will put the values of 0 and all somehow. So 0 is 3. 1 second, just hold on for a moment. F of 0 is 3. Find f of minus 1. Is it some symmetric something? Hmm. This function is neither even nor odd. Okay, let's look at the solution then. What is this saying?
So they've said, they've written the integral as integral e power x bracket open e power x square dot ax plus b plus e power x square dot a plus e power x square dot 2x into ax plus b dx. 2x ax plus b.
Like this.
Yeah, and then dx. And then the next line is just a equal b equal 1.
This is what they've written.
Yeah,
Okay. Uh, let's think of what is so obvious here. Ax plus b is 2x into ax plus. So this is the derivative of. Okay, so they're saying the derivative of this term is going to be this plus this, right?
yeah, right.
Do you understand what is happening?
Yeah, e bar x. Yeah,
So basically, they're saying that don't try to do all this. Don't try to get it as a function of whole thing.
yeah,
They're just saying e power x keep outside and bring the e power x square inside.
right,
2x square plus 3x plus 2 like this.
right.
And try to split this as a function of x, right?
Yeah, right.
So some function of x plus f dash x.
Yeah,
So then they are saying that e power x square times ax plus b's derivative will be e power x square times a plus e power x square times 2x times ax plus b, right?
right. Yeah,
So again, here they have taken a general f of x as e power x square times ax plus b, right?
right,
And from this, okay, so 1 second. So basically, they are saying you can see all third terms have e power x square. So they are saying e power x square and inside ax plus b plus a plus 2x into ax plus b.
yeah,
This thing should be equal to e power x square 2x square plus 3x plus 2,
right. Yeah,
right?
yeah,
So basically now you can say that it is 2ax square plus 2bx and 2ax. 2bx plus ax plus b plus a, right?
right,
Multiplied by e power x square. From here, a is coming 1, and if a is 1, then b is also 1.
right.
Hmm. And then because it is like this, they will say that the answer will be e power x. This is my f of x.
Yeah.
E power x square into ax plus b,
Right.
right? Okay. So your answer will be e power x plus x square, x plus 1.
Right. And then plus c because they've given f of 0 is 3.
That's fine, but was there a way to get it directly other than this? X plus 1 or x plus x square, x plus 1. So there should be a by parts way, no, now. Like the integral is this. So the derivative of this should be equal to the integral of this is coming out to be e power x plus x square into x plus 1, right?
Yeah.
So derivative of this is e power x plus x square 1 plus e power x plus x square 2x plus 1 into x plus 1, right?
Right.
2x plus 1 into x plus 1 plus 1
Right.
is 2x square plus 3x plus 2,
Right.
right?
Yeah.
So here, if we had done 1 plus 2x square plus 3x plus 1, we could have factorized this 1 plus 2x plus 1 into x plus 1. But still, we would not be able to guess how to handle this thing. Right. So the trick is basically not to try to fit the whole thing, right?
Right.
The trick is to keep it e power x. So our basic term is not e power t, it is e power x only. And
Right.
inside the function is this, right?
Yeah.
And this inside function has to be written as a function of x plus f dash x,
Right.
right? So he's saying in general e power x square into ax plus b if it was my f of x. The derivative is e power x square a plus e power x square 2x ax plus b, right?
Right.
So our combination function is the combination of these things, right?
Right.
We are going to say that 2x square plus 3x plus 2 must be 2ax square plus 2b plus ax plus a plus b, right?
Right.
Correct. But this is not obvious, and the point is to not to try to take it as d, right? Because that makes it really hard.
Yeah.
If we had just this inside function, then we could we don't have to think of another variable. We have to think of the same x only,
Right.
which would have been, if this was the problem, maybe we would have figured it out, right?
Yeah.
Because we just have to split it into two parts in x.
Yeah.
I think we would have done this if it was like this. So the point is to do it like this and not to try to take it as 1t.
Right. Yeah.
Okay, what else? Tell me.
That's it.
Have you been practicing your chemistry?
Yeah.
Okay, and 3D, how is it going?
What's that?
3D geometry.
Oh, yeah, I've been revising the PYQs.
Okay, let's do a class on today's Friday, right? Let's do a class on Sunday.
Okay. Yeah.
Get all your doubts in 3D or whatever weak chapters you need to revise for physics and maths.
Okay.
Try to get as many doubts as possible
Yeah. Okay.
for whatever is weak in physics and maths, and then what we'll do is uh, basically what I want you to do is spend most of your time on chemistry revision.
Yeah. Yeah.
Try to clarify your doubts in the class, whatever doubts are there. If you have some issues in some chapter, we can discuss some concept also if needed.
Okay.
But don't spend time doing physics and maths concepts and all right now, or questions and all right now. The only time you should do that is in the test.
Yeah. Right.
How is chemistry revision going?
Yeah. So I I'm doing organic right now.
Hmm.
Uh, like I'm revising most of organic.
You're looking
And
through NCERT, right?
yeah, I'm reading all the NCERT chapters again.
So
And
there is a Marks app on that. There is line by line NCERT questions. So just to help you with the revision, you can use that,
okay.
especially for chemistry, for inorganic and organic. If you have
Okay.
this app, there is a section in it, line by line NCERT questions, exemplar questions, and whatnot.
Yeah.
Go through that for your revision. Make sure that inorganic and organic, at least you have done that. Like you should know NCERT completely, 100%, right?
Right. Yeah.
If NCERT is done, then you should be doing last 2 3 years PYQs for whatever chapter you're preparing.
Right.
Okay, so do that and make sure that chemistry is sorted and you can score around 75 80 there. That's the main thing.
Right. Yeah.
If you are able to get to that level, then other things will take care of themselves. Then you don't have to worry much.
Yeah.
For example, right now I'm seeing this NCERT questions for chemistry, and in every chapter they have made many questions. Like polymers, 159 questions, biomolecules, 324 questions. So
Okay. Yeah.
you should just go through all of it. It will help you revise.
Yeah.
So Marks app, use that and go through this section. Okay.
Right. Yeah.
Like there should be nothing, no stone left unturned types.
Yeah.
Don't be lazy about mugging up stuff. You have to mug up right now.
Yeah.
Okay, fine. That's all for now. We'll continue in the next class then.
Okay.
Hmm.
Thank you, sir.